All right, so we talk about Bitcoin a lot. Now it is time to talk about other cryptocurrencies. So since Bitcoin started this game, all other following cryptocurrencies are referred to as alternative coins. Okay, and for Bitcoin supremacists, actually these coins are unnecessary or bad replicas. But in reality, they are really nice alternative coins like Ethereum. So let's see why there are alternative coins, because some people also wonder, why don't everybody use Bitcoin, but instead we have thousands of cryptocurrencies. Actually, in the past, thousands of cryptocurrencies also died. So there are a lot of alternative coins going around. So question is, are they meaningful and why there are such cryptocurrencies? So I will try to explain why and what are the differences between Bitcoin and other cryptocurrencies. So the invention of Bitcoin led the way for other cryptocurrencies, because you can simply copy paste the code, make a small modification and create your own cryptocurrency. So you can even do it in 10 minutes. So thousands of similar Bitcoin and cryptocurrencies were introduced to be the next Bitcoin. Most of them use Bitcoin source codes. Also, this is why most of them use the same cryptographic algorithms as Bitcoin, like the elliptic curve digital signature algorithm with the same elliptic curve. Hundreds of cryptocurrencies died due to lost interest of the users and miners, software bugs, which actually at the end allows attacks that made people lose most of their cryptocurrencies. 51% attack if you don't prepare your mining algorithm in a nice way. This is what would happen. Cryptographic weaknesses in the used algorithms. There were some sometimes implementation errors, but sometimes the used algorithm for mining had mistakes and so. So this kind of thing actually made more than 1,000 cryptocurrencies die in the last 10 years. Then question is, why are we introducing Bitcoin alternatives? So I will list some of the reasons and I will then try to detail them. So higher coin cap, this is one of the reasons, because in Bitcoin we have a cap 21 million, and since a lot of people joined the game late, so if you if you learn Bitcoin today, then you will realize that 19.5 million of them are already mined. So you are not at the beginning of the game, and you cannot earn a lot from this point on. Faster transactions, recall that in Bitcoin it was 10 minutes. Coin introduction rate, some people want to have more coin in the system so that they can trade easier. More transaction per second. So initially Bitcoin was around 4 or 5 transactions per second. Smaller transaction fees, because price of Bitcoin increased a lot, so we are paying a lot of transaction fees. GPU-friendly mining. We have ASICs for Bitcoin mining, and GPU miners got angry because they had a lot of GPUs, so they decided to find mining algorithms where you cannot introduce ASICs. Some of them succeeded, by the way, but some of them failed. And finally, scripting language with more capabilities, where Ethereum here is the game changer, because Bitcoin's script language was not Turing complete, but Ethereum's scripting language is Turing complete, which allows you to do almost anything you want. So let's start with the first one, higher coin cap. Total Bitcoin amount is fixed to 21 million. Actually, it is this, not exactly 21 million. Scarcity of the Bitcoin results in high prices. So this is why people, wanted to have other cryptocurrencies where you have more coin, so that the prices will not go that high, so that everybody can buy and sell. Circulating Bitcoin is much less due to burned Bitcoins. At the early years, the Bitcoin was not that expensive, so people were burning their Bitcoins just to make a point. Okay, so this actually resulted in thousands of lost Bitcoins, which we cannot, recover. And since it was introduced in 2009, from that time to today, a lot of hard drives and laptops were broken, so people lost their private keys. Actually, in the beginning, they also chose a password to encrypt their private keys, and they forget it. So a lot of Bitcoin are already lost anyway. And sending Bitcoin to wrong pay-to-script hash addresses also made people to lose a lot of Bitcoin. Even recently, if you just press a single wrong button, the transaction you make actually got lost. I have seen a lot of examples. For instance, if you write the address to a paper, then type it in yourself. Sometimes people mistake A with D, so they send the money to an address that doesn't exist actually. So we actually don't have 19 million in circulation. Also, Satoshi mined in the beginning a lot of Bitcoin and haven't spent them yet. So, the circulation is much less. So many alternative cryptocurrencies have higher supply limits, like billions of them. So their aim is to have a cryptocurrency at the price of $1 or around that, so that when you make a transaction, the transaction fee will be in 1 cent or even less. So some alternative cryptocurrencies have no supply limits. This is important because although Bitcoin make the upper limit, in Ethereum we don't have an upper limit. So this is a misconception, because at some point people said that there will be a lot of Ethereum in circulation, and the Ethereum founder said that actually it is not possible. They actually calculated something, and you wouldn't have this many Ethereum until 2100. But we actually probably they made a calculation error, because we reached that point a few years ago. So for this kind of wrong claims and blog posts, people think that there's a cap at the top for Ethereum, but actually not. Currently, before proof of stake, we were giving around 2 Ethereum to miners, and we never limited that. Okay. Faster transactions. This is the second reason to introduce an alternative cryptocurrency. Bitcoin block addition time is 10 minutes. A common practice is to wait for 6 blocks, which equals to, 6 times 10 minutes is 1 hour. So that you wait for 1 hour to be sure that the transaction is included in the blockchain. For maximum safety, it is recommended that for the irreversible sale of items with value comparable to the block reward, a large number of confirmations, for instance 144 blocks, which actually happens in 1 day, is required before completing a Bitcoin exchange. This is important because, if you are transferring thousands of Bitcoins, if you send them and it is written in the block, since it is thousands of Bitcoins, miner rewards becomes significantly less compared to this transaction. So a 51% attack is meaningful at this point. They can spend the money and then perform the attack and so on. So as you can see, this is a long time. Such long waiting times prevent Bitcoin to be used as fast payments, because people didn't understand this at the beginning. People told me that we can, instead of using MasterCard or Visa, let's use Bitcoin. But at a bar, you cannot pay for a beer like this due to transaction fee, but also for the timing, because you cannot wait for every transaction. You cannot wait 1 hour. For instance, in the supermarket, at the desk, you can pay it, but then you cannot wait 1 hour, right? Just to prove that it is written in the blockchain. So it is not that it is not designed for actually shopping like this, okay? But for money transfer, it is meaningful, because waiting 1 hour or 10 minutes is not that much of a problem. But for this reason, alternative cryptocurrencies reduce this time. Almost every alternative cryptocurrency have average block addition time less than 10 minutes, some as small as 12 seconds for Ethereum. Okay. So they're even less than this amount. But of course, if you shorten this, sometimes in the proof of work, you have many conflicts, because people solve the problem at the same time. But even for the proof of stake, if you don't have proper equipment, you may be late, and you cannot keep up with this process. All right. So Bitcoin. Another reason is the coin introduction rate. Bitcoin introduction rate is halved in every 4 years. So initially the reward was 50 Bitcoin. But once you mine half of the total Bitcoin, this happens almost in every 4 years, you halve the reward, okay? So most probably next year, around March, most probably it will be less than 30, because in the last days, people mine faster. It will be around this, okay? So this is the coin introduction rate. Some alternative cryptocurrencies have halving in every 1-2 years, because halving sometimes causes a hype, okay? They want to, create this hype, and so that to increase the prices and so. So some cryptocurrencies prefer this kind of halving. So in theory, in Ethereum, there is no halving. This is why I'm saying that the upper limit is, there is no upper limit for Ethereum. But of course, Ethereum Foundation makes many updates during the process. For instance, when they moved from proof of work to proof of stake, what they did actually was 3 halving. They halved the reward 3 times by just moving from there to here. Some alternative cryptocurrencies use fixed coin introduction rate, like in the case of Ethereum, but with an update this changes. So I will talk more about this when I talk about Ethereum. All right, the 4th reason for creating an alternative coin is the more transactions per second. So some people want to, compete with MasterCard or Visa, which exceeds 2,000 transactions per second. This is one of the reasons why you cannot use Bitcoin for shopping, because if everybody in the world tries to use it for shopping, you have to wait a lot of blocks for your transaction to be included. So this is why more transaction per second sometimes preferable. But this depends on block addition time and block size, right? Because you can reduce the block addition time, which would increase transaction per second, right? Because what happens is as follows: you have 1 megabyte of block size, and you add a block in every 10 minutes for Bitcoin. So if a block, 1 megabyte block can have limited amount of transactions because you limit it. And since you write it in 10 minutes, you divide this number of transactions to this kind of minutes to see how many transactions can actually be written on the block per second. So if you reduce the block addition time, for instance, if you halve the block addition time from 10 minutes to 5 minutes, this number will be 10. Similarly, if you double the block size, this number will be again twice. But in order to make it 2,000 or more, you have to modify them a lot. This is why it cannot be, you cannot make an easy modification to Bitcoin and do that. So some alternative cryptocurrencies reduce block addition time to increase transactions per second. Some alternative cryptocurrencies increase block size to increase transaction per second. Also, some alternative cryptocurrencies do both, okay? Smaller transaction fees are another reason for having an alternative cryptocurrency. So Bitcoin transaction fees depend on the network demand and Bitcoin price, right? Because if there's a lot of demand, you have to, increase your transaction fee so to be guaranteed that it is included in the block, because miners choose the transaction which pays the most transaction fee. But you can say that I don't want to pay a lot of transaction fees. In theory, you can even pay 0 transaction fees. But if you make it really small, miners can add other transaction forks due to demand. Okay, so adding other transactions make you to wait a few more blocks to be included. So, for example, transferring $5 worth Bitcoin may require $5 or $50 worth Bitcoin transaction fee, which makes it hard to use in daily life for small purchases, right? Because this fee actually depends on the demand and also, network demand. Here I'm talking about number of transactions that is trying to be written on the blockchain. But also, since you are paying the price in terms of Bitcoin, if the Bitcoin price is really large, paying 0.0001 Bitcoin becomes a really huge amount of money. Some alternative cryptocurrencies require very small amount of transaction fee, but this may encourage selfish miners to avoid including these transactions in a block. So there's also a catch here. All right, the 6th reason, GPU-friendly mining. Bitcoin mining is based on double SHA-256 computation, which requires negligible memory. Recall SHA-256 They are performing logical operations, modular additions, and rotation operations, which are really fast and logical instructions. But you don't need to use a lot of memory here, so you can really optimize it on an FPGA, then burn it into silicon and create a dedicated hardware that we call ASICs. So a GPU or a CPU cannot compete that kind of devices in terms of speed, but also in terms of energy consumption. So they perform more hash operations per watt compared to GPUs or CPUs. So thus, GPUs cannot compete with ASICs in Bitcoin mining. Some alternative cryptocurrencies like Litecoin promised ASIC resistance. Okay, they said that their mining algorithm require a lot of memory, so nobody can build an ASIC that is faster than GPU. So in theory, you can always build an ASIC because you're just optimizing the algorithm on the FPGA, then burn it into silicon. But if the speed is less than the GPUs, then there's no point of doing that, right? But also, building an ASIC is not that easy, You have to go to a factory and really burn it into silicon. So in order to mass produce such a thing, you should really earn some money at the end, However, many ASICs were built in the past for mining algorithms that were claimed to be ASIC resistant. For example, memory-intensive scrypt algorithm is used in Litecoin to be ASIC resistant, but scrypt ASICs are available for current parameters. So let me briefly explain this. Okay, so let me read the next sentence and then explain this. So one can modify scrypt parameters to prevent building efficient ASICs, but this also makes mining solution verification inefficient. So let me explain how this goes. So in scrypt, actually, what you are doing is calculating a lot of hashes in a serial way, and at the end, the results tells you all of the calculated hashes you are going to use which one is determined by at the end, like a random value that is generated at the end. So, I mean, for instance, think about this. In a serial way, you calculate 10,000 hashes, and at the end, it says that, okay, use the third hash. So you have to go back and use that. So if you store them on the memory, this will be really fast, right? You will just go and take the value from the array. But in an FPGA, if you're going to store all of these, you need a lot of memory, and this actually slows down the process, but also you need to use a lot of gate equivalents to store all of these stuff in the memory. So initially they thought that if you choose this number really large, ASICs cannot be built, but actually people really made a good optimizations and created ASICs. So here what we can say is that actually when we're saying that one can modify scrypt parameters to prevent building efficient ASICs, this means that you can actually increase the number really to a large number, like billions or more hashes. So at the end, you have to store all of them. On GPUs, it is not a problem. Currently, we have even GPUs with 20 gigabytes of memory. So building such an ASIC will be really costly. But the thing is that if you increase that number that much, and somebody solves the mining problem, you're going to verify it. So you're going to make all of these calculations again. So it will take minutes or sometimes hours for you to obtain the same result. So there's a problem here where you can increase the parameters to prevent ASIC building, but increasing it also increases the verification time, which makes the algorithm inefficient. Think about Bitcoin. You are working for 10 minutes to obtain a hash result that starts with a lot of zeros. But when somebody says that I found the solution, we simply check it in milliseconds, right? So this is the problem. So there are ASICs for Ethereum's ETH mining algorithm, but Bitcoin miners also profit mining ETH. So before the proof of stake, actually we had both GPUs and ASICs. But due to memory constraints, because Ethereum mining algorithm actually requires more memory in a linear way when time goes on. So there were some problems here. I will talk more about it when I talk about Ethereum. But currently Ethereum is proof of stake, so this is no longer a problem. All right, GPU-friendly mining, we continue with that. So some cryptocurrencies use multiple hash functions in the hopes of ASIC resistance, because they say that if you use more than one algorithm, the ASIC builders have to optimize all of them. And since we are using more than one algorithm, they have to put it on the chip, so it will require more area, so it will be more costly. So they started with X11. They said that let's choose 11 hash functions from the SHA-3 competition. These are, most of them are the finalists, and the other one are from the previous round. So they say that when you try to solve the mining puzzle, instead of calculating double SHA-256 as in the case of Bitcoin, let's calculate, first use Blake. The result is fed to BMW, then Grossel, and so on and so forth. And at the end, you check if your result is less than a value. In other words, if it starts with a lot of zeros. So if it doesn't, you repeat this process. So this was initially thought that, they're hard for ASIC builders to design something, but actually there are ASICs for this. Okay. So in order to make things a little bit more complicated, they added 2 more algorithms, and Hamsi is somewhat slow compared to all of these algorithms. So it was a little bit harder to build ASICs that can, beat GPUs. But if I'm not mistaken, there are also ASICs or X13. So I think you can see how this is going. So they add more algorithms to make it a little bit more harder for the ASIC builders. So here at X16, they added SHA-512 even to make things more complicated. But at the end, here actually they can. I don't know if there are any good ASICs for X16. They can do it most probably, but in order to do it, you should profit, right? So if there isn't any well-known cryptocurrencies that uses these algorithms, so building an ASIC for you might be a bad idea, because you might be investing a lot to build ASICs, but maybe you cannot sell them to people. Okay. So to have a good resistance for ASICs, actually, they also say that let's not use these algorithms in the same order. So let's say that in every block, depending on the solution of the previous block, let's use these algorithms in a randomized order. So the previous block's solution actually tells you which algorithms and in which order you are going to use these 16 algorithms. It is very hard to build an ASIC for this kind of stuff. And finally, there's something called X17, where you have some more algorithms. So there are cryptocurrencies which uses mining algorithms as these. Okay. So GPU, you can only use GPU for this kind of mining, because nobody can build such a nice ASIC for this. So because people in the past used their GPUs for Bitcoin and Ethereum, and they lost the game for ASIC. So this is why they want to keep their GPUs and they want to continue mining. This is why they introduce new cryptocurrencies where you can mine with GPUs. Okay. Yes, final reason for introducing an alternative cryptocurrency: scripting language with more capabilities. So Bitcoin scripting language is a sequential language simply called script. Okay. Bitcoin deliberately avoided for or while loops to avoid infinite loops, because recall that a transaction actually is a code that you write in the scripting language, and every node actually runs that code. So if you put an infinite loop in that code, actually you create a denial of service attack. So in order to prevent this, Bitcoin said that let's not allow for or while loops in our scripting language. So it is really kept simple. So this is why you cannot do a lot of tricks. For instance, if you want to sell NFT or that kind of stuff, since you cannot create smart contracts like in the case of Ethereum, you have to, write your codes in a very clever way to make the things work. Thus, it is very limited in terms of programming. This is called not Turing complete. In other words, this means that you cannot do everything. Like in the cases of programming languages, we have like C, Python, Java. They're all Turing complete because you can actually write everything and the CPU can perform all of these operations. Here you cannot do that. Ethereum scripting language Solidity is an object-oriented programming language that is Turing complete. So you can actually write whatever you want. So Solidity makes it possible to create and run decentralized applications and smart contracts. This is the nice thing. So instead of simply writing only transactions where you send cryptocurrency from one person to another, here you can write some code like decentralized application, or called DApp, or smart contracts, where all of the nodes run the same code with the same input and obtain the same result. So in a decentralized way, you build an application, right? So this is actually here important. Here I'm not saying distributed, I'm saying decentralized. This is really important because when you say distributed programming or distributed coding, the idea is that you have more than one device and they do the operation in a, they do not do the same operation in a decentralized system, right? For instance, you have a database, maybe you divide it into two, and you keep some data in one of them, and you keep the other in the other one. In a decentralized application, all of the nodes do the same operation. So this is not for distributed programming. Okay, this is really important. Some people didn't understand it, and this is why they say that even my Raspberry Pi can perform more operations compared to these decentralized apps. So why are we doing this? So because since everybody is going to run this script, you cannot actually make very complicated applications here. So you have to keep it too simple. And final thing I should add, here I said that Bitcoin avoided for and while loops to avoid infinite loops. Now I'm saying that Ethereum uses Solidity language, which allows infinite loops because it is Turing complete. So the correct question to ask then, can we perform a denial of service attack in Ethereum? Because it allows infinite loops, right? Yes, you can create an infinite loop in a Ethereum transaction or smart contract or this kind of applications. But the thing is that when you run a code like this, you initially pay gas, saying that for this operation, you limit how many gas you are going to use. And gas is a fee determined in terms of Ethereum, right? So even if you run the infinite loop, when all of the nodes are running the code, your gas will be reducing for every operation they do. And at some point, you will run out of gas, and the program will return false. So they will not do anything, but all of the gas you pay will be lost. So this is sometimes actually happens in smart contracts with a mistake. I mean, the smart contract designers sometimes make a programming error. For instance, in NFTs, we have seen this. So you try to buy an NFT, you pay the gas, but you run out of gas due to programming error where you ran into an infinite loop. So your gas runs out, so you cannot buy the NFT. Okay, so this is why you should have open source codes for this kind of smart contracts. But we are going to talk all about it when we talk about Ethereum.